the surface of the ocean. We don't have data, and this is taken from satellite observations. You can actually back out the wind stress from radar scattering data. We don't have that over the land because the technique doesn't work over the land. Whiter is faster, more white is faster, and the advective texture shows you the directions and so forth. So here you can see that what's called the polar vortex. So the atmosphere kind of gets going around Antarctica too. And that kind of largely forces the Antarctic circumpolar current. Here you can see your hurricanes. Right? They go by pretty quick because again we're stepping through the data at a couple days per second. But these are real data. This is actually what the atmosphere was doing on these dates. The red and blue here are from the ocean model again, and they're showing excess heat in red and a deficit of heat in blue in the surface temperatures of the ocean. And that actually allows you to see heat exchange between the atmosphere and the ocean. You'll notice that these hurricanes, when they spin up, tend to form in red areas where there's a lot of heat near the surface. But when they spin up, they tend to leave these blue trails. They tend to consume a lot of heat from the surface waters and also blow that warm water aside and churn up cold water.
You can watch the seasons of the hurricanes.
Yeah, so now we're in full hurricane season for the eastern U.S. late summer. You can kind of see these storms developing and then tracking into the U.S.
There's a move from Nino to Nina there, I guess.
Right. And you can kind of see that these hurricanes that hit the east coast of the United States, they're kind of pretty small detail in this whole mess, right? I hope that gives you an appreciation of how hard it is to model these things. You really need to kind of
And this was El
go
Nino.
global to do the whole thing. But we don't have, even with a computer as big as ours, we don't have the resolution to do a global simulation and get length scales all the way down to the hurricane eye, which is only a couple kilometers across. So there's all sorts of tricks people play with embedded grids of increasing refinement and so forth. Clearly, you also have to, if you're going to forecast these things, you got to model the ocean, and that's kind of providing all the heat and so forth. So it's a really, really hard problem.
Here comes Hurricane Katrina.
Yeah. So here's Hurricane Katrina, actually, which is right at the end of August. It's right about there.
Ah.
And then this is Rita right here, and then Wilma. It kind of bounces off Yucatan right about there. So yeah, that was pretty active.